All right, let's make this short and sweet. I have done 5 of these modules today out of the 28, and I got onto last modules I did were antennas 1 and 2, and I really struggled with them. I gotta say, and I was running out of patience and out of energy, really. Just I needed to eat something. Yeah, a man cannot subsist on lattes and lattes alone. So I think 5 is good enough for today. I don't know how many I'm going to get done tomorrow. I have to go back to work on the 29th. So that means I have 5 days, well, 4 days, 25th through the 28th, to do as much of this as I can and do some painting. I have Zoe here. I have the Osprey, you can see down there, and another painting that has been waiting for a very long time to be finished. And that's pressure I put on myself. But I ate a whole plate of lasagna, and so then I'm gonna raise a glass to all of you signals operators. There's a bit of red wine. I don't know if you got some moose milk with you or not, wherever you may be. I haven't had a glass of red wine in God knows how long, and I've been letting it air out for a bit. And I'm not hesitant to drink it or anything like that. Usually I'll have a couple of beers, and that's good enough. And, when I can afford to. So this is a luxury. This is reward. So, what can I say I've learned from this? Well, the calculations for the how to make the antennas following, of course, the lambda, which is, and then the wavelength. Excuse me, I got this cold creeping up on me. Which is of course is lambda 300 divided by the hertz, the frequency, if I remember correctly. Just getting that through my head, and then of course they're talking about the gain and how long the boom should be, and how large the elements of the actual antenna should be. So then you have the reflector and the directors from like the emitter, and of course also the thickness of each of these elements, and how if it's going to be a full wavelength, or half a wavelength, or a quarter of a wavelength. And it was a lot of information to digest. And I'm looking at this, and I think that I'm not sure I'm going to pass the exam the first time. It's 100 questions. I haven't done a knowledge-based test like this, again, in a very long time, of this amplitude and this intensity with this much concentration since college. Doing the Garrett Turbo certification and the is it the entrepreneurial certificate from the business school at Western. That was a lot easier. That was far easier. I'm gripping this the wrong way. I'm making it warm up with my hands. So like I'm in this for the long haul. I'm gonna finish this. I think it speaks volumes of what I'm willing to do in order to get to the places where I'm going or where I want to be. And you know, you can't like let any old monkey in front of this stuff, because you know it also seems to encompass, you know, how do you repair or construct your own radio, because again, from what I remember, which all you really need is differential. You need a differential, right? You need a power source, a ground, a lead, and then again it's telling you how long do you need the lead to be, the length of the wire, and if you're going to have anything in parallel or in series. So say something like what's from what I'm just trying to remember this off the top of my head. So you have your AC power or whatever from the wall, or you have your DC power, 12 volt from a battery. Then you have a transformer in order to step up or step down your voltage, and then you have then it's in this series, not this is getting in this series, not parallel in the circuit. A capacitor or a filter. Again, the filter has to be as close to the power source as possible. The fuse. And then a rectifier, so that it will change depending on the output that you're asking for, or from the input rather, to an AC or DC output. Yeah, I think that's it. I'd have to go back and look, but you know, again, this echoes that this stuff was Radio Shack, right? It was far more popular amongst older people because it was the cutting edge. It really was the cutting edge. It hasn't, you know, faded into the background interference by any means. I think that it has reached a plateau. That's how I feel about this kind of research. I think it's reached a plateau, and people are afraid to really move forward with the potential of stuff within this realm, especially with directed energy weapons or with EMF jamming, in which we could quite literally construct an aircraft with a force field in which you could have a signal broadcasted from an antenna on an aircraft that would, you know, like a microwave ionic sphere, because that's what it's talking about. Is this theory? And one of the things it's talking about is this theoretical emission point in a sphere, and the other one being, of course, the toroidal or of the donut kind of emission, and then of course, then the third kind being directional, with a gain in which the element, the transceiver in one direction has more amplitude than in one direction than it does the other. And again, I think this is still the wild frontier in a lot of ways. I think that there's a lot to be gained from this knowledge, and that I think it really is a means of democratizing people in that if you're not smart enough and you're not patient enough, and if you don't have the discipline to stave off the impulsiveness or the instantaneous reward, then you're not going to succeed in the world that is at the forefront of what we see now, especially when it comes to miniaturization and then the ease of manufacturing of remotely controlled devices. And when you look at what's happening in the Ukraine right now, and this is exactly, again, the EMF jamming is exactly why the spooled fiber controlled drones are so popular in field usage, is because they can't be jammed. They just can't be jammed, right? You can't just point points a anti-drone gun or the microwave gun at the object to make it drop out of the sky. Where am I going with this? Well, I'm going through this and I'm thinking about this, like directional antennas and stuff like that from the past, in which the Soviets were broadcasting from behind the Iron Curtain all of this propaganda in a female voice. And then I've seen, of course, the difference being, of course, a horizontal element that broadcasts horizontally in electricity versus an element that broadcasts vertically and bounces off the ionosphere. And it's very low tech. It was very low tech. And that's what I mean, is that if more people understood how this all worked, I think they'd be very angry with the services that they provided. I don't think they'd be very happy. I think that's a real shame. I think the racketeering in which some of these essential services and their providers come to an agreement as to how much approximately a service should cost, irregardless of how much investment or operating cost is required to maintain the physical network, because you don't need cellular towers really to keep cellular service going. You don't need it. And this is if I'm rambling here. Nah, that's it. I'm going to stop there. I think there's still some brain melting to be going on here. It's gonna take me a bit more time. So Merry Christmas, everyone. Yep. How am I going to feel about this at the end of it? I think it's going to be. I should feel about it like I did, like the times I went through ground school, and how much information that was. The first and second time round. Like now, I just it's in my head forever, like so many of my memories, and that's a good thing, and I think that's also something to be respected. So here's to tomorrow. Thanks for tuning in.